Hi, everyone. I'm Andy Chang, one of the product managers on Google's security team. Excited today to talk to you guys about the shared security model, what that means to CISOs. And just an observation before we start, I think the combination of lunch, super comfy chairs, and a long conference, certainly understand if some of you guys doze off. So we're going to talk today really about the shared responsibility model as companies move from wholly owned on-premise deployments to moving to the public cloud. One of the key things really to think about is how the shared responsibility model works. So we're going to talk about first what we've heard enterprises care about in terms of the security. Then we'll talk about understanding really shared responsibility with some specific examples. And then dive into, for GCP, what are the native cloud capabilities that provide you control and visibility. So, what we've heard from customers about what they care about in the shared responsibility, and in security really, is first and foremost that the right data gets delivered to the right identity for the right purpose at the right time, each and every time. And that's the core of security, right? That the right thing happens on an ongoing basis. Next, when you think about how every week, every month, we continuously hear this ongoing disclosures of breaches, the threat landscape is continuing to increase. And what we've heard from enterprise customers is they really want to look for a partner that's really out there assessing, innovating, and getting ahead of threats and risks. The third aspect, for many of you folks who are in businesses that have regulatory compliance requirements, is really enabling you to run your business on a public cloud that meets those regulatory and compliance requirements. And the last thing, and probably the focus of what we'll dive into a lot more detail, is the fact that there's a fundamental difference in the visibility and control that you perceive you get when you run on-prem versus when you're in the public cloud, and really understanding that. Understanding the division of responsibility and how you get the things that you need to be comfortable and trust that things are running the way you want. So as I said, we're going to be focusing on this part. As a general comment, at Google, when we think about security, we think about it as an accelerator to business. Hopefully, as you've seen many of the talks that have been going on throughout the week around security, we look to, at Google, run security in a way which accelerates our innovation. It's kind of the common refrain that in order to go fast, you have to have really good brakes. And so at Google, security is done in concert with development so that it doesn't slow things down, and in fact, enables us to go faster. And that's what we hope for our customers as well. So this is a quick kind of overview of the various different areas that are touched upon when you think about a shared responsibility model. We're going to cover each of these in some amount of detail, but the key thing is that all of these are places where there is a dynamic between you as the customer and the public cloud provider to think about the different pieces of shared responsibility. If you have attended any of the previous Next and some of our infrastructure security talks, this graphic will be familiar with you. At Google, our core philosophy is defense in depth at scale by default, and we think about our own security stack really in 9 specific layers. The core part of this for you to understand is as a part of the key platform on Google and Google Cloud Platform, these are the controls and visibility pieces we take care of ourselves around the core platform and the underlying infrastructure. And you can see from hardware all the way throughout to usage. The 2 key things I want you to take away from this are, number one, at each layer, there are multiple stages in defense in depth. So there's no single point of failure across any particular layer. There's also no single point of failure across the horizontal the vertical up and down between layers. So we think about all these different controls in place for the services that we create on top of which you build. Now, when we think about the ability for you to do your part of the shared responsibility model, I've redone the stack in a way to think about what is Google's responsibility. It's the managed underlying infrastructure from the foundation, so the hardware, the boot, the operating system, the inter-process communications, and then on really 3 different places where we provide either direct products, and those are the things in the green, where partners provide products to help you take your part of the responsibility, And then in the gold, where both Google and partners provide products. And our philosophy with partners and with customers is, if you have a set of tooling that you want to use, you're familiar with, we're going to try to enable you to do that because that's in your comfort zone. But there are also going to be places where we have products that overlap what some of our partners do. So at a high level, you can see across the board, there are different options for you to fulfill the different pieces of the shared responsibility model. If we talk more specifically about the shared responsibility model, there are really 4 kind of key items that most CISOs, most folks moving to public cloud think about. First, you're building on top of a set of services provided by the cloud provider. And it's really about understanding those and that infrastructure being different than the infrastructure you're used to building. Secondly, the visibility and control points of running on a public cloud provider are different than what you're going to have in an on-premise situation. Third is to both learn, understand, and leverage the native controls and visibility tools provided by the cloud provider to get you to the same outcome. In other words, to prevent the same threat vectors and attack vectors, but not necessarily in the same mechanism. And finally, how the customer and the cloud provider collaborate in order to deliver that end-to-end ability to deliver on security and the shared responsibility. So first off, at a very high level, when we think about shared responsibility, something to point out is depending on the type of service you use from a cloud provider, that boundary for shared responsibility changes. So if we go kind of left to right, if you're completely on-prem, then not surprisingly, you are responsible for every piece of the stack. And the stack goes to, again, the hardware, the software, the low-level software, the operating system, storage, network, all the logging, what you run on top of your machines, the network security, operations, what your application security, usage, users, DDoS, all those pieces. Now, as you take one step over to the right, you're predominantly in infrastructure as a service, where what you're using are really the core underlying services like storage and VMs and firewalls and load balancing from the provider, but you're largely responsible for the architecture. So the cloud provider is responsible for giving you visibility, like in the audit logging, the underlying core software-defined network that runs, and that infrastructural network is responsibility of the cloud provider. Underlying default storage, which is unique to Google, that all data services are encrypted at rest, by default without any effort from your customers. The underlying hypervisor, the underlying OS pieces, those are all still in the cloud provider's area of shared responsibility. But now, on top of that, you typically run your own OSs. You create your own containers, and the security of those things become now the responsibility of you running and leveraging our services, and that moves all the way on stack. When you do PaaS, which is platform as a service, the level of responsibility and division again changes from yourself to the cloud provider. So now you're running a service that we've provided. An example of this is App Engine or BigQuery. So you're not writing code into BigQuery other than SQL queries, right? In App Engine, you're building using languages, so the actual application, but the distribution, management of the instances, the virtualization, that's all operated by us. So there's a lot of pieces now that fall into Google's areas of responsibility versus yours. And the final kind of state is if you're using a software as a service, so if you're using Gmail, you're using Drive, from that standpoint, the full software that you're running has been provided by Google, and therefore we're responsible for those pieces. You're still responsible for securing the data you put on and how you get the data on and off. Thus, you're still responsible for securing how you allow people to have access to that application, but the application itself and how the application runs, both the build, deploy, and then the runtime pieces are owned by us. So this is another layer, another way to think about how the shared responsibility is divided up as you go from unmanaged services to more fully managed services. So this is a quote from Niels Provos, who's a distinguished engineer at Google, one of only about 100 distinguished engineers at Google, and he runs most of our privacy and security engineering teams. And the key here, and we're going to talk a lot about technology, but we're also going to talk about visibility and transparency. And Niels's point was that security, really, and trust is built not only through great technology, but also being as transparent as possible. So us as a cloud provider, it's part of our mission and our charter to provide you as much information as we can so that you have an understanding of what we're doing and what is happening on your systems. So to illustrate this in a little bit more, we're going to talk about kind of the actual threats and threat models that you may think about. And certainly in the Q&A sessions, if we've mixed some threat models, we definitely want to have that discussion. And so, when we think fundamentally around security, you can abstract it away a little bit to saying that you need to secure the access, like who's actually getting at stuff, and the stuff that they're trying to get at, the data. And then you need to secure the platform under which all of this runs. So when we think about the shared responsibility model, Google's certainly responsible for securing the platform, what you're building on top of the services we give you to build the things that you're doing. We're now going to explore each of these other two vectors in a lot more detail and talk about what are the things that Google provides to allow you to secure the different pieces and what is still in Google's sphere's responsibility from a shared responsibility standpoint. So in the first case, when we talk about the identity and access path, it is ultimately, you'll see, a shared responsibility to minimize the risks there end-to-end. And by risks and attack vectors, I mean this. So to give you an orientation, you'll see the same slide, at least framework, on ongoing pieces. So going left to right, to access things happening on applications you're running on a cloud platform. You could have employees, you could have contractors, you could have users. And then if we go left to right on the access path, right, to the cloud, first, if you're talking about employees, contractors, users, identity and phishing, both identity phishing from a human standpoint or OAuth phishing when it's an automated programmatic attack. Another vector is obviously malware, right? Malware that's installed on any of the devices, could be laptops, could be your mobile devices. In the traffic between your users, yourself, and the cloud, can it be man in the middle? Or can there be DDoS attacks that try to do resource starvation on your services? At the boundary of the gap, which is where the arrow points to exploit a gap in policy, when you transition from at the edge of the cloud, are there gaps in policy that can be exploited? Once you're within the cloud, the ability to exploit gaps in control and separation of privilege built into your architecture. And then when you think about the application, is the application vulnerable to cross-site scripting, SQL injection, those type things? So we now think about mitigations. From a Google standpoint, we provide a number of products that help you address each of those pieces along the way, and are focused really on context-aware access to empower you to fulfill your parts of that responsibility. So again, if we start left to right, from a phishing resistance and resistance and kind of authentication, security keys are hardware two-factor, which we highly recommend admins that are running your GCP or G Suite take that as their two-factor solution because it's very, very, very unphishable. In addition, the ability to have OAuth blacklisting. So what that allows us to do and allows you to do is to decide exactly what services, what access services can't have, right? So you control both the aspect of human phishing situations as well as OAuth of compromised situations. In terms of the devices, Google provides Google Device Management, which allows you, again, to run your devices in a managed way from a corporate standpoint. In the path between users, employees, contractors, and the cloud, a number of things. First, the cloud load balancer. So if you're building in any of our PaaS or SaaS services, that's built in by default, right? So all of those are behind our load balancer, so DDoS attacks of that are mitigated by us. And if you're building in an IaaS space, if you used explicitly the Google Cloud Load Balancer product, you then are taking advantage of the same load balancing and DDoS protections that our own services provide. Cloud Armor, which is we announced back in March as our WAF that is natively built by Google. So the ability to do blacklisting, the ability to write rules, to find cross-site scripting, SQL injection, to have that capability. And then also partners. We have partners that you can either get WAF facilities, DDoS facilities from that you can leverage. At the boundary between outside of cloud and in the cloud, we have the Google Identity Aware Proxy, which is the externalization of BeyondCorp, which we'll talk about a little bit more in the next slide. And that allows you instead to have access to applications without necessarily using a VPN, to be identity-based and apply policy at that point, and enforce that policy logically in a centralized way, even though it's actually implemented in a distributed way. Then once you're in the cloud, a lot of the challenges around policy, IAM, and network segmentation, we provide a range of products to help you scope and shape both access and permissions and security zones to match your security needs. So our IAM curated roles that we provide, I think it's over 220 now curated roles you can choose from to allow that built-in separation of privilege. VPC service controls, which allows you to create zones and firewalls at an application services level. Organization policy, which gives you a top-down ability to control what happens and specify what happens at an org level that then gets propagated down through folders and projects. The ability to have private access to GCP services. Our VPC controls in general, our shared VPC, which provides L3, L4 level centralization, and then VPC firewalls, and then VPNs. And then when you get back to the actual application, we provide the cloud security scanner for your developers to use to actually find ahead of them going to production, things like cross-site scripting, mixed content, and insecure libraries. And on the visibility side, so those are all controls. On the visibility side, the Cloud Security Command Center, from monitoring standpoint, Forseti, a range of audit logging, VPC flow logs, and Stackdriver monitoring and Stackdriver logging, as well as partners. And so those together allow you to fulfill your part of the shared responsibility. The pieces that Google takes care of on the access side, if we go again left to right, for Googlers, so if you're concerned about a Googler being compromised and that identity being used to access your data, all Googlers use security key. Again, the OAuth blacklisting, and also within Google, we have multi-party controls. So even if a particular Googler was hacked, there are many situations where it requires multiple folks to actually allow something or disallow something to happen. And from a device standpoint, safe browsing. If any of you are using Chrome or some of the other popular browsers, they all leverage our safe browsing detection for malware and for phishing and for sites. So we have the ability to, because we have a large scope across the world and a lot of endpoints, they have a good sense of whether a website is potentially malicious, whether binaries are potentially malicious, and inform that upfront before they're accessed or downloaded by your users or your employees or contractors. In the path to, and then within Google, if you're concerned about Googlers' devices being compromised, we use our own device management and to enforce policies across all devices we use as Googlers. All Google services, as I said, are behind our global load balancers, so they're DDoS protected. They're also fully TLS'd for all of our services. They also have perfect forward encryption, and they also, we use certificate pinning and in some cases certificate transparency to further protect the path from our Google service, you using a Google service, and the actual cloud behind it. At the boundary, we use BeyondCorp. So as I talked about before, the Identity-Aware Proxy is an externalization of components of our BeyondCorp technology, but BeyondCorp is a core security model that really looks at completely zero trust networks, both externally and internally. And we leverage that as well internally once you're inside the cloud. The zero trust networks give us our ability to separate out multiple tenants, separate access within a tenant, and give us the ability to look through and keep those secure boundaries. And then, as we talked about in an earlier talk yesterday, from an application level, one of the things that's strongly embedded in what we do with our applications that you would use is sandboxing, multiple layers of sandboxing. From a visibility standpoint, as we announced back in March this past year, or earlier in March this year rather, we're the only cloud provider and uniquely only cloud provider to provide access transparency audit logging, which gives you a sense of how and why customers' data has been accessed by a human Googler. And that's something that's unique, again, to Google and Google Cloud Platform. If we now think about the data content side, the way we think about first are what are the possible, again, attack vectors. So one of the attack vectors is a compromised insider. There's an attack vector around misusing data that's been in the cloud. There's an attack vector around potentially trying to write bad data into your system. But the two attack vectors most customers care about is exfiltration of your data, sensitive data, and also malware patching updates on compromised machines that are on the guest side, and ultimately questions about compromised machines on the Google Cloud Platform side. For the Google Cloud Platform side, on the host side, we're responsible for all the patching of the underlying host OSs and machines that the infrastructure runs on. And we had a talk earlier yesterday about how we did that for Spectre and Meltdown. Everything that we do in GCP is run in a container. I think as Diane talked about in the keynote, we start about 4 billion containers a week. So when we think about your VM is actually running on a container on our host OS. We're responsible for patching our host OS, but the guest OS you put on your VM in one of our containers, you're responsible for. So how do we help you take care of some of those things? So on the VM side, we announced earlier today shielded VMs, which gives you attestation and guarantee that the VM you spun up is running what you spun it up with. Binary authorization, which allows you to actually attest to and sign the manifest of your builds, so you know that what ends up being deployed is what you intended through the build system. Container registry vulnerability scanning. So if you're running containers and you have images in our Google Container Registry, we do vulnerability scanning against those images. Shielded VMs we talked about, and then sole tenancy. So if you are super concerned about isolation, we do offer you the ability in GCE to have sole tenancy. That obviously comes with additional costs because you're now the sole tenant on what otherwise would be a multi-tenant system. If we think about data exfiltration, IAM gives you separation from an access privilege standpoint. Organizational policy we talked about, again, gives you the ability to define at a top level of an organization policies that flow down to each of the projects. VPC security zones gives you the abstraction, allows you to do effectively firewalling and security zone at a services L7 level. DLP, which gives you the ability to actually classify the data and to actually understand and make decisions about the type of data moving across the boundary. Direct Connect and Carrier Connect. So if you're concerned that your traffic is potentially traveling through the public internet, we have a number of peering relationships that you can do either with ourselves directly and where our locations are or with partners. So you have now a direct rack-to-rack type communication so the data never moves through the public internet. And also aligned with that is private access to GCP services. So your ability to not have to hit a public endpoint to use one of the GCP services. The other kind of key pieces that we provide you if you care about potential things that are being uploaded incorrectly, the ability from IAM to provide privilege creation, a risk, kind of web risk API that allows you to get a sense of what's going on badly, and underlying logging and monitoring. If you're concerned about insiders, one of the key things really is around the identities. We give you the ability to kind of verify against those. We give you the ability to choose your level of encryption, either our default encryption, custom managed encryption keys, the ability to use cloud HSMs, and then also the ability if you want to supply your own key using customer supplied keys. And then again with data classification and DID, the ability for you to, on a programmatic basis, detect the sensitivity levels of what you care about. And then from a visibility standpoint, very similar to before, the Cloud Security Command Center, Forseti for writing your own scanners if you care about certain types of detections and monitoring, VPC flow logs, and the rest of the logging structure. From what Google provides, again, if we think about the underlying VM updates and patching and malware, first and foremost, we provide live migration. So if we're patching our underlying host OS, we can migrate your workload off of that VM and potentially off of that actual host, do the patching, do the updates, and then move your workload back on. The actually blackout period is in the milliseconds. So you never have to reboot the system. The system actually in the workload stays running. We move all the network connections, we move all the actual memory, and then we move it back. And that's a core to both how we just generally do maintenance, patching, updates, and it's also especially critical in our approach to how we handled Spectre and Meltdown, where we patched everything before the actual announcement went public, and without any impact to any customers' workloads or customers actually having to do any effort. So something which was really for most folks, a fundamental flaw in microprocessor designs for most modern microprocessors, and something that affected the entire industry, was actually a non-event for anyone who was a Google customer. In addition, with the behaviors within containers and across VMs, we have an anomaly detection for unusual behavior, and we've defined at least 2 boundaries, our own version of the configuration of KVM, as well as our purpose-built virtual machine monitor, which allow us 2 boundaries of separation to, again, isolate anything that's trying to break out from one VM to another. For the rest of what's built into Google, a lot of these come down to really 4 key principles. Zero trust networks, so you have to explicitly authenticate to connect between different networks. Default encryption, so again, all data services are encrypted by default without any effort from customers. Our own identity and access system, which allows us to track and log who from a Googler side is accessing things, and then multi-party controls. And then from a visibility standpoint, again, access transparency logs, so you get a sense of what's going on from Googlers if they need to access your data. So we're going to dive now more into visibility and control. And what we're going to do is talk first about kind of the concepts of what are the things that folks need for control to protect data. There are really encryption controls, network controls, and authorization controls. And on the visibility side, classification of your data, so you actually know what's sensitive and where it is, and then monitoring and logging so you can figure out what the actual set of events are. So first on the visibility side, data classification is key. We're generally available with our DLP technology, which does a range of things. It gives you flexible classification of data. We have 70+ different detectors for multi-national and international data types for PII. You can also choose what kind of de-identification action you want to take with the API. Do you want to do tokenization? Do you want to do data masking? Do you want to do format preserving encryption? We also have a great deal of effort focused on re-identification analysis and k-anonymity. So really the ability to think about differential privacy, understanding what amount of data becomes identifiable and changing actually the nature of the data that gets processed so that makes sure there's a particular level that you can set around how identifiable the data wants to be. And so that all allows you to do 2 things: classify the data and decide what you want to do with some of that sensitive data when it comes in. And this is the same technology that's used in Gmail, in Drive, available as a DLP API, which allows you to use it either in your own applications or use it in a scanning mode, which allows you then to look at buckets in GCS or tables in BigQuery and understand where your data is. So once you know what your data is, you have data visibility and classification, then that allows you to guide policy about the sensitive data. Cloud Security Command Center, which we announced in public alpha back in March, gives you an overall organization level view of what you're running on GCP, and also allows the integration in the one place where all the finding sources that have risk information, vulnerability information, threat information join in one place, so you can actually make decisions in aggregate across what you're running on GCP. So in addition, we have audit logging. So across the range of services, both in admin activity logging, and this is any changes around metadata, as well as, and that's on by default. It's append only, and you can, through Stackdriver, search on it, filter on it, alert on it. And then we also have data access logs, which actually are actions on the data themselves. Those are off by default because of the volume. You can choose to turn them on for each of the services that are supported. They are on BigQuery, I think, by default. And then we talked about access transparency. Right? So access transparency is a type of audit log that gives you a log of accesses by human Googlers, whether they're doing it manually, whether they're doing through running code, when they access your data. And this is for cloud and app customer data. It can be surfaced through an API, it can be surfaced through the Cloud Security Command Center. And what we found with the customers that, and not surprisingly, over 99% of all accesses by Googlers to customer data is directly the result of a customer's request for us to access the data to do something, fix it, take a look at it, do other pieces of it. And you get that justification with each access. So you can go look at it, ask questions about it, and that either is available through the API or through the Cloud Security Command Center. In addition, getting back to Niels's point of trust through transparency, there's a range of third-party certifications across many standards, both US and international. We keep a public web page that updates. You can look at that and see the updated amount of compliance standards. And each of these, and we're going to continue to add to these, are really meant to address two issues. One, confidence and trust you can place in our platform by not just trusting us, but trusting a third party who's actually assessed it and certified it, as well as your ability then to understand which standards apply to run your business. So now we're going to talk about control. So we finished talking about visibility, and now the control side of things. So one of the key things that's unique about Google in Google Cloud Platform is we provide you a lot of organization-level top-down controls that you can enforce policy with. So to make sure that, kind of using more common vernacular language, Google has a sense of an organization, folders within that organization, and then projects within folders. Projects within an organization are most akin to either accounts in AWS or subscriptions in Azure. And we provide an organizational level view of all of the projects. So that would be equivalent to AWS and Azure, the ability to see across all your subscriptions or all your accounts. And that allows us then to provide policies that apply organization-wide. So first of those is not surprisingly IAM. So I think this had like 220. I think we're over to much more over than 220 now. We start you off with a set of curated roles, which divide up the typical CRUD type permissions, and that allows you to start with a good template of who and match the particular roles they have with the type of services they have. We also, if that doesn't exactly meet your needs, allow you to customize those policies. So you can then match a set of policies to how you use, but even if you start out of the box, there's already built-in separation of privilege. In addition, we have our resource hierarchy. So the structure I talked about, organization, folders, projects. So those are separate security zones by default, both in terms of networking and IAM. So projects do not share networks unless you explicitly authorize those projects to share networks. And then policies or roles that you have in one project don't transfer to another project unless you explicitly add those roles for that project as well. So that, again, provides you guardrails as you spin things up. Customers have used that in a number of ways. Customers have used projects as a boundary between essentially test, staging, production. They've used it conversely, if they're cloud native, as the boundary around a full service. So if they may have thousands of microservices, they may have thousands of projects. So each service is its own project, and again, its own network and IAM boundary. There are both many ways to use that level of abstraction, but allows you, again, to control the blast radius, define roles that separate out what they can do at a project level versus a folder level versus an organization level. The next piece in the upper middle, VPC service controls, which we've talked about both here and also in the conference, is really around providing you that top-level services-centric ability to create security zones, the ability to separate out and define which instances using which services can talk to other VMs and services. So the simplification is to say essentially services-level firewalling the ability to create that permissioning for each service. Can or can it not talk to this set of instances and devices? And what that, in addition to what's included in that, is the ability as well to provide private access to GCP services so that you don't have to actually go out to the public internet to access a GCP service. And that's especially critical for some of our customers who don't want any opportunity for their data to actually move in the public internet. In the upper right, we also have, as we talked about before, the identity-aware proxy. And the way to think about that, and the last thing I'll talk about, which is shared VPC, is that on GCP, we provide you logically central control points and choke points that are implemented as fully globally distributed ones. So if you're used to historical network policy and network security, folks build bastion hosts or jump hosts, which then narrow down and neck down where all the traffic goes to, so you can inspect everything and you can control flow through there. So those are conceptually useful because they are that central place where things funnel in, but they are, when they're implemented in the on-premise world and traditional network security, they are performance choke points. The key advantage of Google Cloud Platform around this is we give you those logical centralized control choke points, but it's in a fully distributed way, so there aren't the bandwidth restrictions. So at an L7 level, that's applying policy through the identity-aware proxy, and then at the L3, L4 level, it's using our shared VPC, which is its own separate project where you can define all the firewall rules that a large number of other projects are slave to. And so those are 5 examples of top-down organization level control. So another thing, as you think about the difference between cloud and your on-premise situation is, again, as we talked about, the network security model. So traditionally, the way the traditional security model works is there's an outside and then there's an inside. And your goal as a security provider or a security CISO or security engineer for your on-premise thing is stack as many things in line between the outside and the inside. That's kind of, and whether that's firewalls, that's appliances, load balancing, everything is basically stacked through there, and those kind of create the choke points. When you think about the cloud is an overall surface. The entry comes through a global, essentially, front end. And then you have the ability to separate out web services, but you have lots of microservices and applications running within the cloud that need to be separated from each other as well. So the east-west versus the north-south becomes equally, if not more important. It's not perimeter-based, and then you need to create flexible groupings to allow to handle those more dynamic network policies, or else you're just trying to map the old architecture into the new state. To give you even more detailed sense of that, this is kind of that right side blown up a bit. If you think about the top as the outside world and then what's happening within, first from outside to in, whether it's Cloud Armor as a WAF or IAP as the identity-aware proxy, that helps you manage your ingress traffic. If you think about the inherent VPC firewalls, that allows you to map and control traffic between VMs. And then if you think about VPC service controls, that allows you to manage both ingress and egress traffic for services, as well as for GCP services or Google services that can now be constrained both so that they can't write outside of your organization, as well as they can also only be accessed from private IPs. The next piece of control is data protection. So just in terms of managing what can move where, there's also the ability to control like how the data is represented. As I talked about before, all the way to the left is the default encryption, fully automated, nothing you have to do. All the data at rest is encrypted without effort from the customer. All the way to the right is where if you want to manage through off-prem and your own keys that you running your own key management system, you just want to push us the keys at the time that we need to use it, where we therefore do decryption in memory. We have customer-supplied encryption keys, which are available for compute engine and cloud storage. And the middle, which is where a lot of folks tend to operate, is the ability to leverage our own key management system, which works at scale and is the same one we use at Google, but you have your own tenant for that, and be able to then control the key operations, rotation, creation, deletion. Also have full logging and IAM controls of who can do those actions. So that's the spectrum that can be added on top of the other controls. And then the last thing to talk about from a control standpoint is how do you make configuration no longer a manual thing? And so if we look at the progression, right, there was CI/CD for code, so kind of a programmatic pipeline to actually build and deploy code. And examples of that are obviously Jenkins, GitLab. Starting to move to config to code, so the ability to think with Chef or deployment manager from Google or Terraform, the ability to actually define what the configurations are, and then moving to policy as code, encoding the actual policies that you want to be able to define the behaviors that should be happening by default programmatically. So the last thing we're going to close off on is an example. So as a way to kind of embody some of the best practices we have at Google, we built out a template security architecture for a particular purpose. So financial transaction app, which had a stock purchase application and public stock dashboard application. So it really has three types of data. Data that is fully public, and that would be the public dashboard application about stock prices. Payment transaction, so you can actually go purchase a stock. And then the back end, which is the transaction management system, whose data should be private. So public data, private data, and then the data that both can be on the internet, but is private or secured, and then data that cannot actually be on the internet. So this incorporated using App Engine to the front end, shared VPCs, containers, Spanner to actually do the transaction processing, BigQuery, and then Stackdriver for monitoring. And so that was an example architecture that we feel other folks can then leverage and expand, extend. So specifically on the control side, it leveraged the resource hierarchy, organization policy, IAM, the network security pieces, the key management system, identity-aware proxy, two-factor authentication or two-step verification, and then config as code. It's deployable fully through Deployment Manager. From a visibility side, it used the Cloud Security Command Center to provide visibility into the resources, Forseti to do scanning around networking and the IAM policies, DLP to understand how to classify the data and where it was going, and then audit logging to track what's going on. From an overall architecture standpoint, you can see basically there's a transition from public to private. So data coming through from an IAP standpoint goes to the stock application. There's a proxy, and that's the path to the transaction system. So you can't, basically that's an isolation boundary. All the credit card information is classified and validated. If you go from the public side, basically the public kind of dashboard app basically comes from an anonymized user. This comes from an authenticated user using two-factor. Goes through a dashboard application, again, proxied away from the actual transaction system. And transaction system actually stores data using KMS and then actually dumps data through logging. If you then look at the network security topology in more detail, shared VPC is at the front end that allows it to define firewall rules across all of the pieces, and then network peering into a set of proxies, back into kind of the transaction system again from isolation. And then there are paths for either from the dashboard application, which is a public application, to take the transaction information and update that through this proxy. And then when you're going through the stock application to do a credit card transaction or a payment transaction, that again goes through a proxy before it goes to the transaction system. So the key for us is we built this on Deployment Manager. You could have also built it using Terraform. Allows us to create the projects and associate them with billing accounts, configures all the firewall and networking situations, and then configures the machines for read-only and also rewrite proxies. The actual DM scripts were broken out to be able to first deploy the projects, create the VPC. There's a script needed to enable the shared VPC, then Deployment Manager for both the private to public to private path, the fully public path, to update the DNS, and then to deploy out the transaction infrastructure, the botnet infrastructure, which then generated random transactions, scripting to set up peering, scripting to create populate spanner, and then one manual step to enable IAP, and then to actually deploy the applications. So from this level, it's really using DM to programmatically define the configuration and deploy it. So I'm going to summarize. And where we are then is, again, from a shared responsibility model standpoint, the cloud provider really is responsible for securing the infrastructure of the platform. Customers secure their data, and they also are responsible for securing how they use the services of the platform. And then our view is that cloud providers are also responsible for empowering you as customers with those visibility and control features to allow you to secure yourself. So with that, I think we have maybe a few minutes to take questions. I think there are mics on the side. And I appreciate you guys staying awake through this post-lunch in these comfy seats. Thank you.